Hello everyone, welcome back to Organic Chemverse. In this video, I am going to teach you how to match the reagents given in column 2 with the reactions given in column 1. So let's get started. I'm going to solve this question in two different methods. In the first method, I'm going to tell you how to choose the reagents required for the reactions within 1 minute. In the second method, I'm going to elaborate the reactions and tell you what sort of reactions the molecules are undergoing. At first, observe all the reactions given here. The reactant molecule is common, which is either undergoing nucleophilic substitution reaction or elimination reaction. In the first case, it's undergoing nucleophilic substitution with rearrangement. So if you don't know what is the reagent, you just forget it and move on to the second reaction because that could be simpler. Here it's undergoing dehydrohalogenation and hydrogen is removed from less sterically hindered side. So for that we need a specific bulky base which is nothing but potassium tertiary butoxide. Therefore B matches with R. The third reaction is quite simpler. It's the nucleophilic substitution where the bromine is treated with the simple aqueous KOH. So C matches with S. In the last reaction, it's undergoing dehydrohalogenation. For this, we need a simple alcoholic KOH medium. And where do we have it? In P. What is left here? A and Q. So A matches with Q. So this is how you can solve it within 1 minute. Now let's see how these reactions are taking place with respect to the reagents used here. Especially for the first reaction, I'm going to explain in detail. So when the alkyl halide is treated with the Ag plus ion, what happens? The bromine will leave as bromide. So AgBr will be the byproduct and you are going to get a secondary carbocation. When secondary carbocations are formed, they're not so stable. So there is a common hydride shift happening here. When the hydride shifts here, you are going to get a tertiary carbocation. So we know a tertiary carbocation is more stable than secondary carbocation. So that's the reason the hydride shift is taking place. So finally what happens? The water, which acts as a nucleophile here due to the presence of lone pair of electron on oxygen, it will attack the carbocation and it's going to form a complex like this, right? It's not stable. The hydrogen will leave as proton and it's going to form a product. So what you understand from here, whenever we use Ag plus ion, formation of carbocation takes place. Hence there is a rearrangement. Therefore it's going to form a tertiary alcohol rather than a secondary alcohol. Therefore A matches with Q. Let's check for B. So as I mentioned earlier, there will be 3 hydrogens here on this carbon. What happens? The specific base, the bulkier base will take this hydrogen as proton and dehydrohalogenation will become simpler. Therefore, B matches with R. Now, for the C reaction, it's nucleophilic substitution without any rearrangement. For this, always remember aqueous KOH. Many students get confused between aqueous KOH and ethanol KOH. Remember, aqueous refers to nucleophilic substitution reaction. The ethanol or alcoholic always refers to elimination reaction. So this is very, very important. So therefore, C matches with S. And D, as I told you earlier, it's a elimination reaction. Here it's not specific. So what happens? It's going to remove hydrogen so that we are going to get a highly substituted double bond. Highly substituted double bonds are more stable due to hyperconjugation. That's why D matches with B. Thank you for watching this video. In the next video, I'm going to solve some more IIT JEE advanced level question. And if you have not subscribed to the channel, please do subscribe and support me. Thank you.